Hello guys, in this video we are going to see today's SKILLRACK daily challenge and daily test solution. So first we see daily challenge solution. In today's daily challenge they given a question that contains an integer n and k, and we need to convert the integer n to the smallest minimum possible integer x, and by modifying at most k digit in given n. And the note is, after we converting integer n to x, it should not contain a leading zeros. So, and the boundary condition of n is in the range of 1 to 10 power 7 and k is 1 to 7. So, in input of our first line contains n and the second line contains k value, and we need to print the modified n value as a output. So now I am going to tell you how to modify our given n integer n to integer x. So for that first I am going to assume our first test case as input. So our first test case is going to be this. So our k value is 3 and the n value is 51528. To convert given n to x value, I get a input integer value n as a string, and I going to iterate from beginning to end. So at the beginning I initialize I pointer at the beginning. So I am going to check if the beginning digit is greater than 1. So if it is greater than 1, I convert current digit to beginning digit to 1. And for after changing each of the digit, we need to decrement our k value. So after decrementing the k value going to be 2, and I need to increment our I pointer. So after incrementing I pointer, we are going to check second digit value. So the second digit value is greater than 0, we convert it to 0, and we need to decrement the k value. So after incrementing I to third digit, we need to check if the third digit is greater than 0. If it is greater than 0, we convert it to 0, and also we decrement our k value. So when our k value reaches 0, we need to print the input, because we only change the utmost k value. So our result of x value is going to, if we match this x value, and the output of the first test case is going to be same. So our algorithms work same. So let us also consider a second test case as an input. So in beginning the given value is 1. So if we convert the 1 to smallest integer of 0, then it contains a leading 0. In question they mentioned that our modified integer x should not contain a leading 0. So we leave the beginning value. So after I incrementing I pointer to the second integer, I need to check if it is greater than 0. It's not greater than 0. So I simply increment the I value, and the digit greater than 0. So we need to convert it to 0. Decrement the k value by 1. So and moving I pointer, the current digit is 0. So simply moving I pointer, the current digit is greater than 0. So we need to convert it to 0. After converting it to 0, we need to decrement our kth value. So our k value is to be 0. So when our k value is 0, or we reach the end of the number, we need to print the x value. So our x value is going to be 10,000. So if we match this x value and the second test case output, it's exactly match. Now we also consider a custom test case input. The beginning digit is greater than 1, so it's not. So I simply increment my ith value. So it's 0, I simply increment, and then also 0, I simply increment. So for the if this 7 is greater than 0, so I need to convert this 7 to 0, and after converting I decrement the k value by 1. So after decrement, there is no digit to modify the given integer n to the lowest minimum. So this is our lowest minimum of the n. So we need to print this value. This value is going to be 1000. So this is our algorithm. So now quickly see the code. I already written the code. In first line I get the n value from the user, and in second line I get the k value from the user. So in first line you can see, as I mentioned before, I get the n value as a string. In this if condition, I am going to check if the first integer of the n is greater than 1 or not. If it is greater than 1, we need to convert our first digit to 1, and we need to decrement our k value by 1. So in this for loop I going to check rest of the characters from the first index. So we need to terminate our loop when we reach end of the string, or we reach the k value as 0. So in the for loop I going to check if each digit is greater than 0. So if it is greater than 0, I convert that digit to 0 and decrement by k value. After for loop getting terminated, we get our minimum possible integer, that is x. So we need to print this. So now we going to analyze the time complexity of this code. So the time complexity of this code is O of n. So the n represents the number of digits the integer n contains. So and the space complexity is going to be O of 1. So because we did not any extra space in our code. So that's all about today's DC. Now we move to today's daily test solution. In today's daily test, n people are standing in the queue to buy a cinema ticket, and the n people have a value, have a amount 150 and 25, and the exact cost of our ticket is going to be 25. So if we able to give all the peoples the change amount, then we print yes. If we did not able to give a change to the people, we need to print no as a value. So for that our n boundary condition is going to be 1 to 100. So and our program first lines contains the n value, and the second lines contains n integer value that represent how much money to have, and our output is going to be yes or no. To solve today's question, now we assume our first test case as an input, and I tell you how to solve it. Now we are going to consider a first test case. To track each of the money value, I am going to initialize a variable to count how many 25 we have, how many 50 we have, and how many hundreds we have. So initially all the value is going to be 0. So for first person I get him money. So after getting 25, I need to increment 25 count. So and from second person, after getting 25, we need to increment our 25 count. So after getting third person 50, we need to increment our 50 count, and we need to give a balance of 25. So we need to decrement our 25 by 1. So and for fourth person, we get this money 50, and so we need to increment our 50 value, and we need to give 25 as a remaining value. So it's 0. So for this test case, we can able to give all the changes to all the persons. So now we going to see another test case as a input. So now we are going to assume this test case is as another input. So now I am going to get 25 from first person and 25 from second person. So after getting 50 from that person, we need to give 25 as a change to that person. So increment our 50 count by 1 and decrement 25 count by 1. So after getting rupees 100 from fourth person, we need to give 75 as a remaining. So for giving 75 as a change, we have two possibilities. The first possibility is going to be we can give 325 rupees as a change, or give 125, 150 as a change. So in our case, we have 125 and 150 value. So we need to give those values to the person 4. So after that, increment our 100 value to 1. If you closely notice that there is no amount larger than 100. So because we did not need to track the 100 value. So simply tracking 25 value and 50 value, we can able to predict the output. So this is the logic we are going to use to solve today's daily test. So I already written the program. So in this line I get a number of people standing in the queue, and in 8th line I initialize 25 count and 50 count. Initially I set all the value to 0. Initializing this value, I use while loop to get money from each person one by one. So I use a temporary value to get money from each person. So if our t is equal to 25, we need to increment our 25 count. Or else if our t is going to be 50, we need to increment our 50 value and we need to give change as a 25 value. And before we giving a change, we need to check if our 25 count is greater than 0. So then only we can able to give 125 as a remaining. In this else if we check if our t is 100. So if it is 100, we have two possibilities. We can either give 25 125 or 150 as a change, or we can able to give 325 as a change. So in this in this else if I check if we have 125 and 150. So if it is both the value is greater than 0, we can able to give change to that person. So if this condition fails, our if else goes to this if else. So in this if else, I going to check if we have 325 value. If we have 325 value, we definitely able to give a change to that person. So if none of the condition above is satisfied, we are going to else condition. The else condition is going to execute when we have no amount to give a change to a particular person. So if we cannot able to give a change to the particular person, we need to print no and we need to stop our whole program execution to avoid unnecessary printing of yes. So if without else, if all the condition is satisfied for each of the person, we need to print SS output. Now we analyze the time complexity of the code. O of n. O of the n value is going to be number of person in the queue. So in space complexity of our code is going to be O of 1, because we did not use any extra space to compute the output. So that's all about today's DT. Thanks for watching. Bye.